Hello guys, today we're going to talk about inheritance in Rust. There are one things I will confuse that Rust is not support inheritance natively in the language nowadays. So then how we do inheritance Rust nowadays? So that are the key questions for this lesson today. We use Java to easily to compare with the current way. So in the string, we have Rust, the symbol model in uh, in inheritance in our language Java, and then we have the A class, which is the base class of B class, and C will be inherited from P class. So in Java, let's take a look how we implement in Java. Okay, so here, hold on. Yeah, I have here, we have the Java side. Okay, so actually we have one class here. Okay, this is Java code. So on that part, in Java code. So basically we implement the class A first. Publish, publish publish status class A. So class A, we just have the functions uh, function FAs. Okay, so this function is very easy. Just print out something. Uh, okay, then we will try to implement another ones. EFL2. Yeah. Okay. Okay, we have FI2 here. And hold on, FI2. And then we have FI2 here. Okay, so this is class A. So we want the class B will inherit to from class A. So we have publish plus class P is stands from class A. Okay, so we also have two functions, something similar with what we have here. Okay, so basically we have AP and AP2. Okay, let me change this one to AP. Okay, AP2. So another class is class C, which is just in inherits from class B. It stands from class B. Okay, so this class C do nothing. So what we will do in Java, we have C equals to new C. Okay, then from C we can call F1, or C we can call FB, whatever we want. So it's very straightforward. So we run it. Okay, so we can have class B, FP and FI callings. Okay, I need to change this one into P. So yeah, so we can run this again. You can see here we can have FA and FP running successful. So basically class C will be inherited in from the class A and class P. So in Rust, then what happened in Rust is they don't have the inheritance support, natively support in the language. So we sim how do we convert this model normally we see in Java into Rust? So in Rust, okay, let's start from main. Okay, so in Rust we have concept is trail. So trail is very similar to interface concept or abstract class in Java. So we have to do trails A, and then we define a person's the FA. So if you take, we need to specify cell here. So the FA. So we don't have any person here, and then another person is FA2. Okay, then we need to implement another one is the trail P. So trail P here will be FP. It will be FP. FP. Okay. So the class C inherits from class A and B in Java. So it's similar in class B. Class C will have to implement the trail I in trail P. Okay. So so we have the struct. So in Rust it's a struct. It uses the struct to similar with concept with class in Java. So next thing we have the struct C, and now we need to implement struct C. Implement A for struct C. Okay, so we need to implement FA. So this one we just need to print this EA FA. Okay, and then another one is we need another person. First one, this EA FA2. Okay, so basically, oh sorry, this one need to be a string. Okay, so yes, so after implements the trail A to C, then we have C has support two functions FA and FA2, and then the same thing we need to do for the class trail P. Okay, so basically we have FE here. Okay, this one is P. P here. P here. This one is P. And this one is P. Okay. So okay, so this is how we do in Trust. And now let's say we have a C variable which is instance of struct C. So from C here you can, okay, let me move this one. Let me go a bit here. Okay, here. Okay, so now C here we can call FA. C we can call FA2 also, and then C we also call FP, and then C we also call FP2. Okay, so we just run it. Yeah, so you can see here C structures already have the functions of FA and FP from the trail A and trail P. So it's quite similar, but it's not exactly similar with Java functions. Okay, so this is how we implement inheritance in trail, in Rust. Sorry. So there are a problem coming into this model. Let's say we have so many class E, D, F, which is inherited from B. Then what we have to do in this model, we have to implement the trail A or P and P for every single struct E, D, and F, right? So it will create a massive duplication codes for that. So there are a way in Rust we don't have. In Java, we just very easy. We just extend from B, then that's it. But in Rust, we need to have a workaround solution using basically there are two ways to do it. Most of the thing now there are two ways to do it. We use the first of all we need to use the macro, the object trails and the macro. So here I already implement. Yes, so basically we have a trail A and trail B as usual, and then we need to define a struct called commons or marker trail. You can name it anything. And then after that you implement commons trail for C and D or even E here. Let's say structs E here also can, and then implements commons for C for E. So after C, D, E have the trail commons, then after that we can implement A for every struct which where the struct have the common trail, right? So that means we don't need to duplicate duplicated code to implement FA for struct C, D, and E. So this is very straightforward, but I do find this one is okay way to implement that to show that problem. Okay, so let's see. We need to run this one. Okay, then let me change this one. This one. Okay, so we need to change the name here. This one is inheritance use marker tray. Okay, then let me come back here. Okay, so now we already let me implement the same thing for let me go to E. So E equal to E. Okay, so E also have a person A. E also have person FP. So you can write, huh? Yes, so you can see here C called trail A, trail B, and E called trail A, trail B again. Okay, so that's the commons. This is one way to solve the problem, to avoid the duplications code in Rust when we have multiple class inherit from one class. So, but there are another way, which is I think the softer versions to show this problem is using macro. So everything in the Rust we use the macro. So I can see that a lot of people use macro in Rust. So basically we have one trail A, for example. Let me change this corner. So we have another trail B, for example. So we have function FP. Okay, so this is another trail. So here we can have a struct E. We can have another struct D. So we can implement trail A for any type by using the macro implement A. The same thing we can do for trail P also. Okay. So here we just implement trail P. And this one is FP, not F's anymore. So okay, this one we should change it to FA, and here same thing, FA. Okay, so here the struct C, D, E will can implement the trail A and trail P using the macro. So here we can do track P, C, no, is this one E, D. Okay, then E is okay, and then we can do the same thing for trail P. Then this one it will avoid a lot of code duplication. So here is supposed to be FA, and then we can call FP on the trail P, and this one is to be E, and then this one E. Okay, we can have another one ED. Okay, so we can call this one no, this one is E. Okay, then okay, then DFA, DFP. Yeah, so C also can call FP. That's the person from trail P. Okay, let's try to run this one. Yeah, we cannot run U macro. So okay, let me change the name of this one. Use macro. Okay. Okay, let's run it. Now we can run it, sorry. Yeah, you can see okay, this one need to be changed into class. This one should be changed into class B, not A anymore. Okay, so you can see the code is much simpler because you use the macro, the macro. So here we run again. Okay, so we can see A, B, A, P, A. Okay, I need to change the order. This one, A, F, A. So we can have A, B, A, P, A, P. So we have A, P, A, P, and A, P. So you can see there are different way to solve this problem. Personally, in Java is more straightforward because you just need to do like that, and then you don't need to through a macro or the common trail or marker trails anymore. But this is just a difference. I would like to say that it can be, yeah, it's just a difference. But anyway, to be honest, the Rust way is not kind of similar than Java, but I'm okay with this. So okay, so this one is using the marker trail here. Yeah, so that's all for today. So thank you for watching.